Welcome, deep divers. Today, we're diving into a topic that really touches everyone. Climate change. We've pulled from your sources, specifically looking at a guide on debunking climate myths to try and, cut through some of the noise, get to the core truths. Our mission really is to unravel those persistent misconceptions with solid facts.
Yeah, it's so easy to feel a bit swamped by all the information out there, or even, frankly, misinformed sometimes. So our goal today is to give you a clearer, maybe more concise understanding of what the science is actually saying, helping you sort of distinguish between the common myths and, well, the verifiable realities. And what's really fascinating, I think, is how some of these myths just stick around, despite such a strong scientific consensus.
Okay, let's kick things off with one I hear, well, quite a bit. The idea that climate change is just natural variation.
Mm.
I mean, we know the Earth's climate shifts naturally, obviously, but your sources seem to highlight a really critical distinction here, don't they?
Absolutely. That's a key point. What the research you sent over shows is that, yes, the Earth's climate does fluctuate naturally over, millennia. But the warming we've seen, particularly since the late 19th century, it's fundamentally different. It's happening much, much faster. Your sources explain it's primarily driven by human activities, especially burning massive amounts of fossil fuels. The rate and the scale of this current change are, well, frankly, unprecedented in human history. Some studies say it's happening roughly 10 times faster than any natural warming period we know of in the last 65 million years. So that speed, that acceleration, that's what really sets it apart from those older natural shifts.
Right, 10 times faster. Wow. Okay, here's another one I hear all the time. You get a cold snap, maybe a really crisp winter, and suddenly some people might say, see, told you, global warming isn't real. All right. It's easy to get caught up in the local weather, right? Your sources remind us there's a crucial difference here.
That's an excellent point, and it does cause confusion. It really raises that important distinction between, well, weather and climate. Think of weather as, your daily forecast. Short term, variable,
Yeah.
what's happening today, this week. Climate, on the other hand, that's the long-term average. The big picture trend over decades, even centuries. It's like judging a person's overall health based on decades of checkups versus how they feel on one particular Tuesday. Your sources are clear. A single cold day or even a chilly season, that's just weather. It doesn't disprove the long-term global warming trend. That overall average temperature is still undeniably going up.
Okay, so a cold snap isn't proof against global warming. That makes sense. Weather versus climate. Got it. But for a lot of people, maybe the bigger question isn't just about the temperature outside. It's whether the scientific community itself is even, on the same page. Which brings us to this surprisingly persistent myth. Scientists don't agree on climate change. How do your sources tackle that perception? Because it feels quite widespread.
Right. That's a really important perception to address. And the data you shared, it's quite definitive on this. It indicates that over 97% of actively publishing climate scientists agree. They agree climate change is happening and that it's primarily caused by human activities. This isn't some 50-50 split or a divided field. It's actually one of the most robustly supported scientific conclusions we have. It's backed by pretty much every major scientific organization worldwide. Think NASA, NOAA, the IPCC, National Academies of Science across the globe. The debate, such as it is within the scientific community, it usually focuses on the finer details, like the precise timing or magnitude of impacts in specific regions or the best modeling approaches, but not on the fundamental reality of human-caused warming. That part's extremely well established.
Over 97%.
Yeah.
That's a powerful consensus. But even knowing that, sometimes it still feels like a distant problem, doesn't it? We often hear it framed as something, maybe our grandkids will have to deal with. That myth. Climate change is a problem for the future. Is that really accurate, based on what you've seen? Or are we already seeing the effects now?
Yeah, unfortunately, the information in your sources makes it abundantly clear this isn't just a future projection anymore. The impacts of climate change are already being felt today. Right now, we're witnessing more frequent and more intense extreme weather events, things like heat waves, severe droughts in some areas, heavier rainfall and flooding in others. We're seeing sea levels rising, which is already impacting coastal communities, and shifts in wildlife populations and plant life cycles, too. One source mentioned, for instance, that the number of climate-related disaster events globally has something like roughly doubled since the 1980s. So delaying action. It only makes these problems more severe and honestly much harder and more expensive to adapt to down the line.
That really puts the urgency into perspective. Doubled since the 80s. Okay. Which naturally brings us to solutions. And another common concern, maybe another myth we hear, renewable energy can't replace fossil fuels. I mean, Is it actually possible to transition away from traditional energy sources at the scale we need?
Well, what's truly fascinating here, and your sources touch on this, is how rapidly renewable energy technologies are advancing. Solar, wind, hydro, even geothermal. They're not just getting better, they're getting incredibly more affordable. Your sources highlight that the cost of solar power, for example, has just plummeted, something like over 80% in the last decade alone. That makes it competitive with, and often actually cheaper than, building new fossil fuel plants in many parts of the world. And lots of countries are already generating, significant portions of their electricity from renewables. It really demonstrates that a full transition isn't just theoretically possible, it's increasingly economically viable and technically achievable, especially, with ongoing improvements in things like battery storage to handle intermittency.
Right, cheaper sometimes. That's a big shift. Okay, so wrapping this up, what does this deep dive really mean for you, our listeners? I think we've seen that getting clarity on climate change really comes from understanding the facts, the actual data, and being able to confidently debunk these common myths using the kind of precise information you've provided us with.
Indeed. And, knowledge is most valuable when it's understood and maybe even applied. So for you listening, perhaps the most important takeaway is just the power of being informed, using credible sources, and maybe recognizing the subtle ways misinformation can kind of persist, even when the science is clear. Consider this, maybe just as a final thought. How might becoming a more informed voice yourself, armed with these facts, how might that change the trajectory of the conversations you have about this? Not just for ourselves, but, well, for everyone around us. How might that shape the future we're all building?